Hello and welcome back to the channel. In this video, we're building a fully working mobile character controller in Godot. You'll learn how to set up the camera, add a virtual joystick, create a 3D player, and write the movement code so everything works smoothly on your phone. Let's get started. Let's start by adding a sun and world environment, because without these two, our scene has no lighting and no sky rendering. Now I select my floor object. Make sure use collision is on. If this is off, the player will fall straight through the ground. Next, I open the asset lib and search for joystick. I select virtual joystick, download it, install it, and press OK. Now I switch to the 3D tab, click the chain icon at the top, and pick the virtual joystick scene I just downloaded. The joystick appears on the screen and I can drag it anywhere I want. Inside the inspector you can tweak many settings, but we won't change anything here. Now let's create our player. I tap the plus icon at the top to make a new scene. Then inside the scene panel I add the character body 3D. Next I long press the node, choose add child node, search for mesh instance 3D and create it. In the inspector I open the mesh and select capsule mesh as the player body. In transform, from position I set Y to 1 so the player sits on the ground. Then under geometry, material, from albedo I set the player color to blue, for example. Now I long press the mesh and add another mesh instance 3D as a child to this mesh. This time I set the mesh to tourist mesh. This will act like a simple eye so we know which direction the player is facing. From transform, I change the scale from 1 to 0.5. And move it in the front of the capsule. Next, I add a collision shape under the character body 3D. This is important because without the collision shape, our player can't interact with the world. In the inspector, I set the shape to capsule shape 3D, and then from transfer, I set the position Y to 1 so it aligns with the mesh. Now add a new node 3D and call it camera pivot. This lets us rotate the camera smoothly without rotating the player directly. Under camera pivot, add a camera 3D node and name it simply camera. Select camera pivot and from transform set position Y to 1 so it's centered on the player. Then select camera and set position C to 8 so the camera looks at the player. Finally, rotate the camera pivot downward a bit so the camera gets a good angle. Using a pivot node instead of parenting the camera directly gives us a much cleaner control during rotation. Now click the camera and tap preview to check the view. Rename the capsule mesh to player and the main character body 3D to player 2. Select player and choose add a script. Set the template to empty and press create. Then I save the whole player scene. Now we'll go back to the main scene. Click the chain icon and select player TSCN to add it to the world. When I run the scene now, the joystick doesn't do anything yet, and dragging the screen does nothing either. That's because we haven't written the camera or movement code yet. This line tells Godot that this script controls a character body 3D node. Essentially, all player movement and physics behavior will be handled by this script. Now I add camera export values so we can tweak them later. Drag sensitivity determines how much the camera moves relative to the finger drag distance. A higher value makes the camera respond more aggressively. Camera rotation speed controls how fast the camera actually rotates based on the drag input. Using export allows you to tweak these values directly from the Godot editor without modifying the script. Next, I add variables for tracking drag input. Camera input direction stores the current drag direction. Last touch position keeps track of where the finger last touched the screen. Is dragging is a flag to know whether the user is actively dragging or not. These variables are essential to calculate smooth camera movement. Now I connect the nodes we made earlier. Camera pivot is the node that we rotate for vertical and horizontal camera movement. Camera references the actual camera 3D node inside the spring arm 3D. Using already ensures these nodes exist before the script tries to access them. Now I add the input function. This function listens for touch events. When the screen is touched, its dragging becomes true and restores the touch position. When finger is lifted, its dragging becomes false. This allows the camera to only respond when the user is actively dragging. Handling drag movement. Unhandled input captures dragging motion events. Drag delta measures how far the finger moved since the last frame. Multiplying by drag sensitivity adjusts how much the camera should react. This gives a smooth, responsive camera drag effect. Applying camera rotation. This rotates the camera pivot node based on drag input. Vertical rotation X is clamped so the camera can flip over or go below the ground. Horizontal rotation Y rotates freely for full 360 degrees view. Resetting camera input direction prevents cumulative rotation beyond the finger movement. Alright, now our camera coding is complete. You can drag on the screen to rotate the camera, and if we hit the play, we can test it. And as you can see, it works perfectly. However, there is a small problem. If we move the camera down too far, it goes through the ground and the view looks broken. To fix this, we'll use a spring arm 3D, which will keep the camera at the proper distance and handle collisions. Now we fix the issue where the camera goes into the ground. In the player scene, I long press the camera and select reparent to a new node, search for spring arm 3D and create it. Now I reset the camera's position to default so everything is clean. On the spring arm 3D, I set the spring length to 8 and under shape I choose sphere shape 3D. This gives the best collision detection. Now when I run the scene, the camera no longer clips through the ground. Now let's go back to the script so we can start writing the player movement code. Now we'll start by defining some movement variables. This variable controls how fast the player moves. The higher this value, the faster the player will move. This determines how quickly the player reaches their maximum speed. It controls how fast the player accelerates. This controls how fast the player mesh rotates to face the direction of movement. This is the force applied to the player when they are in the air. When the player is on the ground, this value becomes 0. Next, I'll add a variable to remember the last direction the player was moving in. This helps us rotate the mesh smoothly even when the joystick stops. It just stores the previous movement direction so we can keep the player facing the right way. Now I'll get a reference to the player's mesh. We want to rotate only the visible model, not the whole physics body. This gives us access to the mesh so we can rotate it later. Now let's read the input from the joystick or the keyboard. This returns a vector 2 where x and y go from -1 to 1 depending on the movement direction. To make movement feel natural, the player needs to move based on the camera's orientation, not the world. So let's calculate the forward direction from the camera. We flatten the y value so the camera tilt doesn't affect movement. Then normalize it to get a clean direction. We do the same things for the right direction. Again, this makes sure movement is relative to the camera, which feels much better for third-person games. Now we combine the joystick input with those directions. This gives us the final movement vector, and we normalize it so diagonal movement isn't faster than straight movement. Now let's apply movement using acceleration for a smooth control. Move toward avoids instance change and make movement feel more polished. Next, I'll add gravity handling. If we're in the air, we pull the player down. If we're on the ground, we reset the vertical velocity so the character doesn't sink. Now we're on the movement through the physics engine. This applies collisions automatically and keeps everything stable. Next, I'll store the last movement direction when the input is strong enough. This avoids jitter when the joystick barely moves. Alright, first let's see which way the player mesh is facing right now. We check if player is moving enough, then get the mesh's forward direction. We ignore vertical tilt and normalize it so we have a clean direction to work with. Next, we'll rotate the mesh to face the movement direction smoothly. We calculate the angle difference between the front facing and the movement direction, then rotate gradually using lerp angle. This keeps it smooth, no snapping. Now press play and test everything. Drag the screen to rotate the camera and use the joystick to move the player. As you can see, the character moves smoothly and the mesh always faces the movement direction. If you enjoyed this, check out my previous video where I show you how to create a realistic sky in Godot. Thanks for watching and I'll see you in the next one.